Okay, hello everybody. So we read 7.5. It talked about equilibrium and Le Chatelier's principle. All right, now equilibrium, when you got any change, the forward and reverse paths, they're both happening, but they're happening at the same rate. So at any given time, we have equal amounts of both on the right and left. It's called equilibrium. All right, so you should have this document there. Important statement here is that when a system, so if we disturb an equilibrium, it shifts so as to relieve the effect of the disturbance. Now your reading talked about three different ways: concentration, temperature, and pressure. Any change in those will shift the equilibrium, and the equilibrium will relieve the effect. All right, we're only going to focus here on concentration. So if I look at a reaction, and then we're going to change, either add products, or if we add the left, add anything on the left, it means favor the forward. If we add something on the right, it'll mean favor the reverse reaction. If we remove something on the left, well, it's going to shift to relieve that change, and it'll shift to replace it. If I remove something on the right, then the equilibrium will shift to replace that. All right, so here's an equation here. Notice how the arrow points in both directions. That tells us it's reversible. All right, so assuming it's reached equilibrium, let's say we add CO. Well, CO, look here, is on the left side. So if I add CO, it's going to shift to relieve that disturbance. It'll use this up and shift to the right. So it favors the forward. How does it affect I2? Well, look where I2 is. It's over on the right side. So if I add CO, it's going to shift everything forward, and that'll result in more of whatever's on the right, and that I2 will increase as well. Let's say I add I2O5. So here, if I add I2O5, the same thing's going to happen. It's going to shift to try to relieve that disturbance, and it'll favor the forward reaction. How will that affect the amount of CO? Well, look where CO is on the left side. So if the forward reaction is favored, that means the amount of CO will be decreased. It will decrease the amount of whatever's on the left. All right, let's look at this next one. Let's say I add CO2. Well, if I add CO2 is over here on the right side. So if I add anything on the right, it's going to favor, try to relieve that change and use it up. So it'll favor the reverse reaction here. If the reverse is favored, how is that going to affect I2O5? Well, look where I2O5, it's over here on the left. So if it shifts to favor the reverse, then it will increase the amount of whatever's on the left. All right, let's say I remove I2O5. So I2O5, let's see our equation. If I remove that, it's over on the left. So if I remove this, the system will shift to relieve that change. It'll shift to replace it. It'll shift to the reverse. So if the reverse is favored, how will that affect CO2? Well, look, CO2 is on the right. So if it shifts to the left, this is it. Whatever's on the right is going to decrease. It'll decrease that. All right, so I did a few there. Go down here. Now here, notice how there's heat on this one. Just think of heat as a product on this side. So if I add heat, it'll shift to the left. If I remove heat, if I cool the system down, it'll shift to the right to replace that. So we can think about heat as, in this case, it's a product there. All right, hope this helped. Complete the document and turn it in.